and then I'll move into a little bit around the facilities side. And then I'll touch on some predictive server modeling and then finish up with one of my favorite topics, which is circular economy. But one pervasive theme throughout these four areas will be the impact of working together as a community and the scale and the speed at which you can operate. So I'll start by giving you an example. This is the cost of mapping the human genome. Back in 2001, it was well up over $100 million. And as you can see, it has fallen dramatically to just about $1,000 now in 2019. And so what has caused a lot of this destruction in the pricing model? There's a lot of variables, AI certainly being one of them. But one of the more interesting variables is the idea of this community. Now, this research institute has a mandate that anybody that's participating must publish the results of any studies that they do publicly to an accessible database within 24 hours. So that has a really big impact. If I'm doing work on a particular project and I need to share my results, look at some of the impacts that this can have across a particular industry. Now, I'm sure many of you in the audience may be familiar with this book. I was just notified of this book a few months ago. It's by Martin Ford, and I really appreciated the style in which this book takes place. It's an interview style where they interview the top 25 or 30 experts in AI. And as I was reading this, they're getting their opinions on whether or not we're ahead of schedule or where we thought we would be at this particular area of the evolution. But it reminded me of this economics principle around the J curve. And the J curve is essentially saying, am I getting what I paid for, or are my expectations met when I invest in a particular area or an economy? So typically, when you think of AI, you may say, I'm going to hire a bunch of data scientists, I'm going to spin up some public cloud offerings, and I'm going to go market and I'm going to get big results fast. But even with proper execution, you should be expecting a dip. And here's what typically happens is that you get a lot of high expectations at the beginning. Things may not be meeting your expectations. And then you get what is called kind of this, the Gartner hype curve, where everybody's really excited. Then people start to poke holes in whether or not we're where we think we ought to be at this particular stage in the cycle. So throughout that book, there are people that say, well, where are we in this curve? Are we above the line into the tangible benefits, or are we below into an adverse effect on performance? So today, I'm going to share, hopefully, some areas where we think at Open Compute, we're in this tangible benefit phase where we're a little bit above the line. So let's get started. Here's some historical perspective. Back in 2010, this is an announcement when Facebook was going to start building their own data centers. And at that time, their infrastructure was growing quite rapidly. So they got together with the manufacturers and they said, look, if we're going to start from the beginning, what can we remove from the system? What do we need and what do we not need in an IT rack or even a facility? Can we run things hotter? Do we need centralized power supplies? So as they worked through each one of these components, they did one additional thing, and they open sourced their designs at the facility level, at the server level, networking, storage, etc. So with the help of Microsoft and Intel, Rackspace, and Goldman Sachs, they started the Open Compute Project, or OCP. And as of 2 weeks ago, we're very happy to announce that Google has joined the board of directors for Open Compute. So we have over 150 companies working on multiple projects, 6,000 engineers across those projects, creating designs and specifications that can then be taken to market and being used by end customers. So within these 6,000 engineers, you have end customers, you have suppliers, you have data center consultants, you have end users, all working together in a collaborative environment. Here are just a few of the projects. We have around 15 or 20. I will spend a lot of time on a couple of the projects later, which is the Open Accelerator infrastructure project, Rack and Power, and I'll touch on advanced cooling as well. But these are led by volunteers, so they will manage their inbound, or they will manage their separate community And then we have an overarching steering committee that oversees the entire foundation efforts. But there are four key things that drive everything that we do within Open Compute: efficiency, scale, impact, and openness. And let me give you just two quick examples of this in real life. This here is a server bezel. It is the plastic piece that goes across the front of any server. There are hundreds of examples out there of different types of server bezels. And in some cases, people believe this is gratuitous differentiation, or the idea of different for the sake of being different and not really adding any value. Here is an Open Compute server, vanity-free, stripped down, modular design, all front access. And I'm going to call your attention to these green touch points on the edge of these servers. These are designed to where a server technician can quickly remove and replace any component on that server without a tool. This toolless design creates a great deal of OpEx benefits when you're thinking about the number of servers in a data center. So that's one example. Here's another. In a traditional server, 8 40-millimeter fans across the back of that server. In an Open Compute server, the unit height is slightly higher, and we use 2 80-millimeter fans. And there's something that takes place called the fan cube law. And that is, if I half the speed of my fan, I reduce the amount of energy it takes to spin that fan by 7/8. So again, I'm halving the speed of the fan, I'm reducing the energy needed by 7/8. And again, has a big impact on data center efficiency. Here's an example of how SK Telecom has compared Open Compute servers with traditional servers running at various workloads. But we see this across different customers that are using Open Compute versus traditional hardware. You have between, say, a 20% on up to 50% savings on the efficiency at the server level and at the node level. But again, it's not just at the server level, but also at the OpEx. Yahoo Japan is a very big user of Open Compute, and they are meticulous at measuring how much effort is involved in managing an Open Compute server versus a traditional server. And you can see the difference in the time there and how much OpEx they've gained just by moving to this new open source infrastructure model. So moving back to the project, so let's dig a little bit deeper into the Open Accelerator infrastructure project, or what I will refer to as OAI. And this started much the same way that a lot of our projects start. You have a member that says, I'm interested in this common problem I'm having. We need to start working on accelerators. Who wants to work with me in this? And quickly, Microsoft and Baidu raised their hand and said, we'll work with you on that. And this was back in March of 2019. And within 1 year, this is just a subset of the companies that are working on OAI. And you see some pretty significant names: Google, Intel, IBM, Inspur, Habana. Really impressive companies all coming together in a collaborative environment. So what are they working on? Well, as AI infrastructure matures, more companies are producing accelerators. That's great, but it also creates some challenges for integration, interoperability, and a lot of this can take 6 to 12 months to start to make sure all of this works together. And 6 to 12 months is a very, very long time in the world of AI. So they've identified 6 areas where they're going to start working on common specifications and common designs that's going to speed this pace of engineering. One of them is, for example, the Open Accelerator Module, or OAM, also a universal baseboard, security measures, chassis, trays, etc. So here's an example. We have 4 different OAM accelerator modules from 4 different suppliers, all based off of the same specification. Here we have a universal baseboard. And as you can see on the right, now when I can start to interchange and I can work with any of these OAMs on this universal baseboard. And this is a big deal to these companies that are moving quite fast in this space. There's also a disaggregated modular approach. We have a couple companies, Inspur and Hive. This is an example of one of their disaggregated host systems with the UVB and the common tray. And this is how it looks in a full rack solution. On the right, it's a full rack based on OAI. And you can see the different OAM vendors that you could put in either one of these areas, as well as the total kilowatts per rack that you can generate. So pretty exciting stuff, the way that they can work on interoperability to drive engineering and solutions faster. Also, as I mentioned earlier, how fast Baidu was to join this particular project. I thought it would be interesting to show, look at their roadmap from 2016 all the way up through 2019, moving toward an open infrastructure. And now that 2019, their latest solution is OAI compatible. And down at the bottom, I have some links, and I know they'll be sharing the presentations after the event. And I highly recommend taking the time to look at this particular solution and this presentation from Baidu as they go into great detail about their AI infrastructure. So that's the first recommendation I'm going to have for you today, is to take a look at this particular presentation. So the OAI is one project that's working a lot on AI. The other one is rack and power. So with these increased AI workloads, it's causing some innovation at the rack level. So in the past, a lot of the large companies would use their own individual rack for whatever reason. With the advancement in AI and the increase in power density, which I'll get to in a minute, these companies are coming together and putting together a common V3 rack around Open Rack that's going to allow for different flexible power shelves. It's going to allow for some other options with some advanced cooling, which I'll get to in a minute, as well as some air-cooled facilities. So what's happening at the rack level is you see a great deal of hotter temperatures and more kilowatts per rack. So the average in an enterprise data center might be between, say, 3 to 5 to 7 kilowatts. With AI workloads, it's well above that. Can go anywhere between 10 on up to well over 20, 70, 100 kilowatt racks. So the issue with that is that you now have facilities that cannot handle this type of workload. They can't handle the power, and there's certainly, once you get up to a certain temperature, you simply cannot air cool the servers. You can't get them cool enough. So you need to start looking at advanced cooling techniques. And this is going to happen very significantly across Asia and across Europe around the facilities that are currently in place and whether or not they can handle these new AI workloads. Which brings me to the advanced cooling sub-project. And look, simply put, liquid in any form can remove heat more effectively than air. So this group is looking at 3 different areas: fully immersed, some cold plates, and some rear door heat exchangers. And they're doing something similar to the OAI project, where they are working on common specifications, working on common designs. But let me share an example of how a couple of these groups here are working to provide a solution to an existing facility that may be air-cooled, that may want to start to transition to an advanced cooling model, but does not have direct water facility capabilities. So on the left, we have a traditional air-cooled data center. You see the air being flooded down through the IT rack and up through the heat exhaust. In this new way, or this way that they're testing in this particular group, you have what's called air-assisted liquid cooling. So you're using the air facility, you're using the air in the facility, along with some components from cold plates and rear door heat exchangers to create a self-contained loop, a self-contained cooling loop. And this is a big, big deal for those companies or those organizations that may not have a particular water supply, or without water, facility water supply. as an intermediary step for those organizations that want to do some advanced cooling and run hotter temperatures. So this is the second presentation I'm going to ask you to take a look at later. This is the actual case study where the group has done exactly what I presented in the earlier slide around their GPU shelf, the rear door heat exchangers, as well as the cold plate. And there's some pretty promising results. You have the air-cooled solution in orange, you have the air-assisted liquid-cooled model in blue, and you're getting almost 50% more power to the rack using an air-assisted liquid-cooled solution. So this is good news for those facilities because many people aren't going to be able to say, I'm going to run AI, I'm going to go build a brand new data center. You're going to have to use your existing facility in many, many cases. So it's not just at the core data center level. It's also at what is happening with AI at, say, the hyper aggregated, empowered edge. And we've all heard a lot about edge, but here's one example. You have Walmart, who's thinking about taking on Amazon at the edge with computing and 5G. Now in America, over 80% of Americans live within a 15-kilometer radius of a Walmart. So Walmart becomes this great potential edge computing grid all across America. But obviously those Walmarts are not set up to be a data center. So you might be looking at more of an immersion tank or an immersion solution that's climate controlled and fits in a particular space. And so we have groups, again, working similar to the OAI group on immersion techniques. Asperitas, Submer, DCX are just three. So we're covering everything from the core to the aggregated, all the way out to the edge in the way that we're thinking about open source hardware and its impact on AI. Moving on to predictive server modeling. As we move up the stack, say from the facility to the rack level, all the way up into the server and software side, we're going to see more of this in the future. Traditionally, this is the way that a workload is loaded into racks in a data center. All these tiles represent different workloads. As you can see, they're interspersed, not necessarily in the most efficient way, driving up cost and lowering throughput. But with AI and the ability to do server profiles, you can predict the workloads across and the demand across the data center, where now you can redistribute those workloads to drive down your cost and have more efficiency and throughput. This example here that I'm sharing is from Edutech. They did they're doing server profiling. The actual readings are in blue. The predicted volumes based on their server profiles are in orange. And you can see the savings greater than 20% on efficiency with a 97% accuracy in predicting workloads. And that's including heat output and power consumption. So of course, it's not just the small companies. Large companies have been using this technology for a couple of years in their data center with Google and DeepMind, using DeepMind rather to reduce their cooling bill by 40%. So this is a really interesting blog as well. I encourage you to take a look and see how DeepMind is working with the Google data centers to reduce their cooling. So now on to my final and one of my favorite topics is circular economy. And circular economy is this economic model around zero waste and reuse. Some people may simplify this and say, well, it's just recycling, but it's much, much broader than that. And the first area is around heat reuse. Now, when we do something, we don't necessarily throw something away, it has to go somewhere. So what do we do with that stuff that leaves the building or leaves the facility? What do we do with it? Data centers have been really good over the last few years about driving efficiency and lowering their PUE, which is a measurement that data centers use to demonstrate efficiency. And they're pretty good at using renewable energy where possible. The next big wave and the next big challenge for data centers is going to be around how do I reuse the heat? There are certain countries and regions of the world that have mandates around heat reuse from data centers. There are other countries that have a goal saying, well, we want X%. supplied from data center heat to our communities. And of course, in colder climates, you can think of taking that data center heat for greenhouses and for heating. But even in warmer climates, you can start to think about something, an absorption chiller, which is something I know very, very little about, but it does take heat to chill things. And then you can use that across your food supply, especially as you get into this advanced cooling solutions, which are running a much hotter temperature. So even with an air-cooled data center, the air coming out of that data center still may not be hot enough to do anything with it. You still need some heat pumps to get that temperature up. But with advanced cooling and AI, you're running much hotter workloads. The temperatures are hotter. So you can quickly and more effectively use that heat coming out of the data center. And think about all those micro edge data centers around the country. Instead of big data center parks, smaller micro data center around the country, being able to reuse the heat for different purposes. So something I would encourage anyone looking at this particular area is to question, well, how are we going to reuse the heat? What is the end goal here once we start using this data center for higher workloads? Now, moving from the facility to the IT level is even more interesting. There are a couple of organizations that have talked about this. Ellen MacArthur is one of those organizations that talks a little bit about IT, circular economy. There's an organization being formed in Europe to talk through what does a circular economy for a data center mean, everything from the rack level to the server level. And that project is something Open Compute is involved in. But one of the more interesting examples is coming out of the OCP community, and that is IT Renew. Now, IT Renew is a service provider based in America, but they handle decommissioning at scale from the large hyperscalers. So think about the number of servers that the top 8 to 10 companies in the world are decommissioning every year if they're on a 3-year refresh cycle. That's an enormous number of servers coming back into the market. And it's not just the idea of taking out a server, scrapping it for parts, or reselling a used server to some developer. This is about taking the full rack, sanitizing it, putting open systems firmware on this rack, being able to run production AI workloads at scale with second user hyperscale equipment. This is being done now. It's being deployed at scale in Europe and in America. And it's one of my big ambitions for this to take place in India and in APAC. It is an amazing process, and it's a great way for people to start using open hardware, and they'll start to work in a hybrid environment. What we're seeing is people would start maybe with some IT Renew gear, and they'll continue to run IT Renew gear for certain workloads, and other workloads, they may run brand new OCP gear. They're running a hybrid environment just the same way that you're running a hybrid public cloud and private cloud. So this is my third presentation that I recommend that you go watch. And this is from Ali Finn, the president of IT Renew. You can look her up on YouTube, just type in Ali Finn, IT Renew, and you will see her keynotes. And the way that she talks about the circular economy and the impact that this can have, especially on countries like India, is very, very impressive. So we're really excited to help support IT Renew in this process. Of course, you can see some of their products. We have a marketplace on our website. You can see all the different types of servers. So in many cases, you may not need a GPU to be running some basic AI workloads. So we have a lot of different open source hardware on this particular marketplace. You can see the integrated solutions and the circular economy offerings from IT Renew. You can also see something that I showed earlier, which is the Inspur integrated rack running TensorFlow, Kubernetes, and OpenStack. So a lot of different options, even at the networking switch at the rack level and the integrated solution level on our marketplace. Where can I find all these presentations? Well, we just conducted our virtual summit 2 weeks ago. We had over 10,000 people join our virtual summit. So you can go online, opencompute.org, under summit and under virtual summit, and you can log in and you can watch all of the engineering workshop presentations on demand for the next 10 months. And I've highlighted, I recommend checking out the Rack and Power, certainly the OAI group and the advanced cooling solutions to find some of those talks that I referenced earlier. And I do have the links in the earlier slides. So how to get involved. I'd mentioned the marketplace, I mentioned some past events. Of course, we're all over social, but one thing I do recommend, check out the project mailing list. You don't need to be a member to be part of this mailing list. You can hear what's going on in the community to get a sense of, is this something that would benefit my organization? Is this something I would find value in? So I encourage you to get involved. If you have any questions at all, please send me a note, steve@opencompute.org. I'm happy to direct you and connect you with anybody in the community to start trying Open Compute gear, to get involved in the projects. It really is a pretty impressive organization to see how all these volunteers work together in a common group. So where are we on the curve? I hope today that I was able to share just a few of the tangible benefits. It depends on who you speak with, and I look forward to hearing more presentations over the coming day here from Plugin to find out where exactly they feel they are on the AI J curve. So with that, thank you very much. I appreciate your attention, and I will open that up to questions.
Great. Thank you, Steve, for the wonderful presentation. Now we can open it up for Q&A, and attendees may ask their questions in the Q&A box. Well, to start off with, Steve, I have one question. So just as the impact of open source software, what impact do you think open source hardware will have on the AI industry going forward?
So I think you'll see really two areas. One is on the end customer side, and then the other one is on the vendor supply side. So I showed you some examples on the vendors and how they're working together. But where I think it's going to have an impact is when you start to see the customers require open standards for their environment. We recently had some public sector tenders across the world who have specified open compute designs. And the reason they like that is because people and end customers like the idea of a multi-sourcing strategy. We say, well, that's great, I can go get multiple sources, no problem. But the issue is with the integration and driving off of one specification. So what this allows people to do at the end customer level is I can have one specification, this OAM or OAI specification. Then I can go talk to Intel, Habana, AMD, NVIDIA, and say, I need something that fits this particular specification. And that is truly a multi-sourcing, reducing your vendor lock-in strategy. And that is one of the bigger impacts that I see open source in general, hardware, even at the network switch level to the AI level, having on the industry.
And what importance does India hold in this regard? Because India is obviously a huge IT market. And so what kind of adoption do you see here in India for open hardware?
It's interesting because we have not been proactive in India until the last year and a half. So about a year and a half ago, we noticed that we were getting a lot of traffic from India on our website, and we didn't really have any resellers there. We hadn't done an event. It's not as if Facebook and Microsoft are announcing, hey, Open Compute's in India. But about a year and a half ago, we started seeing this uptick in trend, and now the interest is increasing and picking up to where now I have a couple resellers in country. Our open networking switch supply chain is quite strong. Telcos are looking at open networking, and we have some pretty large companies in this exploratory phase right now. But it's still early days. But I'm excited because India is still one of the top 5 countries that visits our website. And that's pretty impressive considering how long we've been in America and all the Asian presence that we've had in the past, as well as European. So even there is an appetite for open source, and certainly we know that from the rich history of open source in India, but there is a growing interest in open source hardware in India. And that's why I ask anybody online that wants to reach out and find out more, please send me an email, steve@opencompute.org, because we're doing a lot more in India, and I'm excited to engage with anyone there.
Steve, we have a few questions in the Q&A box if you can have a look.
May need your help to read those.
Yeah, so there are a few of them.
Okay.
If you go to Zoom, you can find them.
Yeah.
At the Q&A box. Yeah.
All right, got it. First question, do I provide any supercomputing hardware ideas? I'm trying to think on how to phrase that question. Do we provide any supercomputing hardware ideas? So the solution providers, I'm not sure I'm going to answer this correctly, but the solution providers that I profiled in the presentation around Inspur and Baidu, et cetera, we have access to the supply chain that's driving some of these supercomputing hardware ecosystems. So I can certainly connect you with the people that are doing these supercomputer, doing the hardware, and have them share their ideas on what they're doing with other customers. I'm not sure I answered that correctly. Please let me know if I didn't, and send me an email and clarify that, please. IT Renew and OCP hardware. What kind of performance do you think it'll be offered compared to legacy AI's infrastructure? So think about this. The hyperscalers refresh most of the time within 3 years. And in many cases, they're early adopters of the latest platform technologies. So I think the AI is extremely competitive and comparable, especially with legacy AI infrastructure. So anything within the last 2 to 3 years, IT Renew would be able to perform quite well in that area. And I encourage you, again, take a look at their website, IT Renew, their Sesame line of products. You can also go onto our website and link to theirs and check out the IT Renew guys. What can be done to increase open source compute as a community? So there are 2 ways that we see open source communities develop. One is you have a couple customers and companies that say, we have a common problem and we want to solve it. And then they get together and they start a little working group. And we had that happen in Japan. So Open Compute was very hands-off in Japan. They started their own community where a group of people got together and said, we like what Open Compute's doing. We're going to start doing our own meetups and figuring out what's important to the local Japanese community. For example, they have different seismic requirements for earthquakes, something that we don't have in other parts of the world. So they were able to take some of these OCP principles and work on some seismic requirements, as well as an implementation and a deployment guide, and then they're contributing that back to the community. The other way that we see this is our proactive way. So one is organically and the other one is proactively. And I've mentioned a couple of things that we're doing here. This great offer by Plugin to Present helps raise awareness, and we're looking to connect with people in India to then drive some examples and some proof of concepts, and for people to start sharing their learnings, positive and negatively, as they make this transition from legacy to open source hardware. And again, we have the large telcos in India starting to look at open networking, and we have some large e-commerce companies as well, starting with open networking and then moving more toward their core data center for POCs. How do you look at Microsoft's shift entire data center in Europe in the sea? I'm not skilled enough at that particular answer in what they're doing and the positive negatives on the sea. I do know that they had that project Nautica. I don't know. I think that that's one option, but I think some of the advanced cooling techniques are going to outweigh some of the work there that's doing in the sea. And Ali Fenn, who I mentioned earlier, has a great comment that we're starting to run out of some minerals where we might be doing some deep sea mining for some of those minerals, which is not necessarily the way to go, that we need to be thinking about reuse as opposed to draining more resources. What do you mean by publicly accessible database within 24 hours? That means that Human Genome Project has a database with all test results. And it means that if I'm a research institute and I'm researching and conducting a study, that I need to share my results on that human genome study into that database within 24 hours. If I'm a member of that institute, of that research institute, I need to contribute my results to their database within 24 hours. Like Raspberry-based supercomputers, which can be created for small-scale companies. I'm not sure if I could kindly ask you to send me an email and clarify that. Yeah. Some Indian government agencies have a requirement for having hosting in country. Do you have a plan to start an open hardware center here in India? An Indian government is a large customer in IT domain. Yes. We are looking now through our membership community for those members, such as an Inspur or a MyTech or a WeWin, that want to partner with a local service provider to put up an OCP experience center or an OCP lab. And from that, what we've been able to determine is if we have a lab environment or even an experience center, it could be one rack, it could be multiple racks, but being able to showcase this equipment, meaning can I go see it or can I remote access in? This certainly speeds up adoption. And I agree with you that it's not just the Indian government that has requirements of in-country hosting. That's happening more and more. And this is a big deal. When people are moving away from public cloud into more private cloud settings, the cost efficiencies that you get on open hardware dramatically makes you more competitive than, say, running things in public cloud. We have a provider in Africa right now that is offering cloud-based open compute services at a fraction of what people can do for Azure and AWS. Because the cost components within open compute, you gain on the efficiency on the energy, you also gain at the component level because you're not buying a lot of the stuff that you don't need in an OCP server. Hosting, I mean the hardware within the country itself, yes, definitely.
Great. Great. We want to thank you, Steve, for your time. It was really great you coming here and sharing your views on open source hardware. Again, thanks a lot, and thank you everyone for attending this session.
Thank you, everyone.
And if you could repeat your email as well, so that people
Sure.
could. Yeah.
Yes. Steve at opencompute.org. Steve at opencompute.org.
Great. Great.
Great. Thank you very much, everyone.
Yeah.
Cheers.
Cheers.